Welcome, everybody. My name is Nitish Chowdhury. I'm here in two capacities to welcome you. I'm co-director along with Deepak Ganesan of the Massachusetts AI and Technology Center. I also direct the Brigham and Women's Roybal Center for Therapeutic Optimization using behavioral science. And this is a joint session of our two centers. I am thrilled to introduce a new colleague, although somebody who's done work which is highly aligned with many on the screen here today. David Conroy from the University of Michigan. He's a kinesiologist, and you spent his career at Penn State, and in that capacity became the director of a Roybal Center there, and then transitioned quickly to Michigan. And his work really sits at the nexus of multiple things that we're all interested in. So one is behavior change, and in particular, the use of just-in-time adaptive interventions. The second are the use of machine learning, artificial intelligence-based tools to help with the delivery or optimization or maintenance of those behavior changes. The third is wearables and mobile technologies. David's doing some really fascinating work using sensors in water bottles, but using other things, of course, using step counters and other activity trackers, and like many of us have interest in physical technology to support health. And the last is the focus of all of that work on healthy aging, which of course is the focus of both centers that I have the pleasure of representing here today. So it's really in the center of that Venn diagram that David sits. And we've asked him to tell us a little bit about his work. And given the diversity of people that we have with us, I think I'm sure he will be happy to have us pick on any one of those things as we extract sort of interesting things from his talk today. So David, thank you for joining us, and the floor is yours.
Thank you very much, Nitish, and everybody for joining today. It's a pleasure to be with you. The title of the talk that I'm going to present is Progress in Personalizing Content and Dosing of a Physical Activity Promotion Intervention. The work that I'll be presenting, but it's really not my work. It's a team's work of a lot of collaborators, some of whom are on the call today, some of whom may watch the recording later. But I want to draw special attention to Saeed Abdullah, Konstantin Laga, Marty Slominski, Ali Tabshinsky, and Anne Marier, who's recently joined the team to manage the center. The work that I'll share with you has had support from the National Science Foundation and the National Institutes of Health. So thank you to the federal government for supporting science. And for anybody who's concerned about disclosures, I've work that's unrelated to what I'll do today that's been funded by Therabody, WW, and Lululemon. Now, I know you're all busy people, so, and I also should mention, we've had a lot of trainees make really big contributions to this work along the way. Sahan Kiani is working with Constantino now, and his students prior to Sahan have made great contributions. Saeed's had great students working with us, some students in my lab like Bell Liu and Jing Wu. So I just want to shout out to the students who do so much of the work in moving this forward. Now, you're all busy people. Some of you are going to be multitasking, as we are wont to do during webinars. So I want to give you the 3 take-home points right up front, okay? 3 things you can take away today. First, behaviors contextualized, so it really helps us if our interventions can be sensitive to the context that a person's living in. Second, the systems that regulate our behavior are highly idiosyncratic. I act the way I do for my own reasons. You act the way you do for your own reasons. The tools that I'll share with you today for modeling and predicting behavior and determining when to deliver interventions come from control systems engineering. Constantino's brought those to the table, and I've learned so much from working with him. But you'll see some examples of system identification and model predictive control that we use to help regulate the dosing of our interventions. On the content development side, we've started to branch out through this Roybal effort to use generative AI to optimize messages to engage the targets that we're trying to hit. So we're trying to make our interventions much more person-specific to target the differences in how people regulate. And third, the targets that we've hit over the years for moving people, getting them to change their behavior, are oftentimes not the same as the targets we need to hit to get them to stick with that behavior once the intervention is over. So we've got to separate out conceptually targets for behavior change from those that modulate adherence to behavior change. Now, that's the quick version of the talk. The longer version of it takes place now. Now, it feels like I've aged a lot over the last month or so, but it's not just me, it's the whole country. The United States is in the midst of a massive demographic transition. We're going to have more older adults in our population than ever before. In fact, the Census Bureau estimates that by 2034, we will have more older adults than children in the US for the first time. So that's a big switch in the country. Concurrent with that demographic shift, we're expecting to more than double the number of Alzheimer's disease cases by the year 2060. Now, unfortunately, Alzheimer's disease has no cure, and there's no validated prevention strategy at this point in time. Physical activity has been identified as one of the most promising strategies for trying to reduce people's risk for Alzheimer's and related dementias. And this conclusion has been reached by independent groups, including the Physical Activity Guidelines Advisory Committee, for whom I consulted 6-7 years ago, by the National Academies of Science, who wrote the Preventing Cognitive Decline in Dementia report, and by, most recently, the Lancet Commission on Dementia, who identified physical activity as one of the factors that could be targeted in midlife to reduce risk of Alzheimer's. That's the good news. The bad news is that very few American adults are engaging in the recommended level of physical activity. We estimate that about 75% of all adults are not getting the recommended levels of activity. And this problem gets worse as we age. So young adults are the most active, midlife adults have a drop, and then older adults drop even further. Unfortunately, there's no silver bullet that exists for promoting population level physical activity and health. We can see that there are interventions out there. A recent meta-analysis found that the average physical activity intervention is successful at increasing people's activity by about 1,300 steps per day, and in getting about 4% more people to meeting the physical activity guidelines. That's a far cry from what we're going to need to impact population health. So let's go back to looking at how behavior is regulated to see if we can do a better job of engaging the targets that would move the needle on population health through behavior change. So we'll start with this social ecological model. This is a variant of it that I've adapted, but the idea is that behaviors unfold in context, and frequently behavior can be motivated by cues in different contexts. Now, what do I mean by context? Context could mean the social environment. It could speak to aspects of the built environment, like sidewalks, safe neighborhoods. Could be the policies that create parks near where you live. The natural environment's an important context. It's hard to go out running if it's icy sidewalks all around you, inhospitable temperatures. Likewise, it's hard to go outside when it's 120 degrees and you feel like your face is melting and you're breathing fire as you inhale. The digital environment has emerged in recent years as an important context for our behavior, as our attention is increasingly captured by the screens that we carry with us every day. Now, that's all outside of the person. Inside the person, we have another set of factors: the person's capabilities, their physical function, their cognitive function, as well as the cognitive and affective processes that motivate their behavior. But the key isn't just to target the person or to target the context. The key is to find the bridge between the person and the context, and that's where associative learning comes into play. And in developmental systems theory, one of the key principles is that in order to understand people, we need to think about the process, the context, and time interacting within that person to regulate their behavior. So over time, we learn and we start to associate different contexts with different cognitive and affective processes that could start to engage our motivation to move or not move. And that's where we're heading with the work that we do. Now, a lot of this work has roots in the speech, the State of the Union address that President Obama gave about a decade ago, where he laid out a vision for precision medicine. The findings that there's tremendous variability between people in how patients respond to treatment generalizes very well to what we see with behavioral interventions. Some people respond to a physical activity intervention and some people don't. And one of the key things for us is try to figure out how do we get the right treatment to a person at the right time. And the tool that we've used to do that is the just-in-time adaptive intervention. I would suspect many of you are already familiar with this, so I won't belabor the idea. But the concept of a just-in-time intervention at a surface is that if you could find the right time to intervene, this just-in-time moment where a person is vulnerable or has an opportunity to change their behavior and they're receptive to an intervention, you could start to deliver interventions at that teachable moment, to borrow a phrase, and increase the likelihood of creating changes in behavior and downstream changes in health outcomes. And you have to specify how often you test for this just-in-time moment, with these decision points, and what rules you use at each decision point to decide whether or not to intervene or not. Shortly before the idea of JIDIs, as they're known, came out, Bill Riley published a paper about health behavior models that really challenged the field. And he said that interventions have dynamic regulatory system components to guide rapid intervention based on current and past behavior and situational context. He's talking about the potential for digital health here. But he then criticized the field, saying even the current health behavior models may be inadequate for our low-tech interventions. They're too linear, too static, and that limits their ability to guide the dynamic adaptive possibilities that we have at our fingertips now for understanding people in context. People like Daniel Rivera and Eric Heckler and their colleagues have started to try to express our existing theories, like social cognitive theory, as dynamic systems. This is one of the classic diagrams they had, looking at how different motivational processes flow from one into another. And for most behavioral scientists, this makes them recoil a little bit. It's a very engineering-oriented diagram that's unfamiliar to my behavioral science colleagues. What we're more familiar with are ideas from the field of personality psychology, like Walter Mischel's cognitive affective processing system approach, where he says that situations activate these very idiographic cognitive affective networks, so systems of beliefs, thoughts, and feelings that we have. And as those networks get activated, they start to organize behavior. So a person could find that they're in a particular situation and it activates beliefs or feelings that ultimately lead to a behavior. Now, these might be efficacy beliefs or outcome expectations or all sorts of other constructs that we've created in psychological literature. The challenge for us, though, in mobile and digital health is we can't measure these constructs on a fast enough time scale or directly enough that we could do it without intruding on the person's experience to be able to develop models. So what we've tried to do instead is to look at how we can use messages as a situational stimulus that would excite that system, that cognitive affective system, and elicit behavior change. So the premise of our work is that we're trying to learn which types of messages regularly lead to changes in physical activity under predictable conditions. And as we gain data about how people respond to messages in different contexts over time, we could start to leverage those insights to make decisions about when to send different types of messages in future. So the approach we use is to give people wearable trackers. Fitbit Versas were one of the early models we use. I think we're using the Charge now. And we'd send messages initially through an app, more recently through text messages. We created 3 libraries of messages, though. One library of messages focuses on moving more. Another focuses on sitting less. And a third was designed to be a comparator, didn't think it would have any effect. They were just inspirational quotes that were meant to make people smile a little bit, keep their attention, and hopefully have no effect on behavior. We'll come back to that idea in a moment. The other thing that we do in this intervention called AIM is we install an app that tracks location. And we've got some privacy controls on it now. So we build a geofence and only update location when people leave a certain area. But we use that location data to get information about the weather, where a person is. So we're using the natural environment as the contextual influence or the contextual setting for people's behavior. You could extend the work that I'm going to describe using any number of other environmental variables that you can measure on a real-time basis or get forecasts of. But we use weather in our studies, and primarily temperature, but also precipitation. And Constantino and his team used system identification, a tool for characterizing how people respond behaviorally following the delivery of a message compared to what they would have done, according to the model, had a message not been delivered at that moment in time. And we're able to create these impulse response curves that you see on the left side of the screen. And then something that's a little more interpretable to my mind are the cumulative step response curves on the right side of the screen, which shows the summative change in behavior. So you see this orange sit less message peaks at about 90 steps more over the next 2.5 hours after message delivery. So we're going to see a lot of these figures. 0, as far as the step response, is what you would expect if a message had not been delivered. So positive changes represent increased activity following message delivery. Negative changes represent the possibility that activity could actually be lower than expected following delivery of a message. So skipping ahead to some of the key findings. First, we find that behavioral responses vary as a function of the person, the type of message that we sent, that is the content, and the day of week that we sent it on. So we split the model up, used piecewise models to have a separate weekend and weekday estimates. So weekdays are on the top, weekends are on the bottom. These are the step responses to messages. And I'm just showing 2 people here, person A on the left, person B on the right. And you can see person A on weekdays, they're most responsive to the sit less messages. But on the weekends, that response, while still dominant for sit less, it's much stronger. Now, instead of increasing by about 90 steps, they'll increase by 175 steps from a single message. Person B, on the other hand, responds to both sit less and move more messages on weekdays. But on the weekends, for some reason, those messages have next to no effect on their behavior. But we see that the inspirational quotes that were just meant to put a smile on their face were the ones that got them moving, and moving quite a bit, it looks like. So we see this behavioral response to standard message libraries, static libraries, varying from person to person as a function of day of the week and the type of message we sent. We also saw that the temperature outside made a big difference in terms of how large these responses were. Now, this is one person's data, but we've broken it out where we see the move more responses in the left panel, sit less responses on the center panel, and the responses to the quotes in the right panel. The top row are responses in the weekday model, bottom row responses in the weekend model. So on weekdays, for this person, if you send them a move more message, they're really not going to move at all, any more than they would if they'd not gotten that message. But if you sent a sit less message, you could get a positive increase in behavior. In fact, the warmer the day was, the larger that increase in behavior was when they got a sit less message on a weekday. The quotes for this person on weekdays only worked on the hottest of days. On weekends, those move more messages, which have been completely inert on weekdays, all of a sudden showed a really nice progressive response as the temperature increased, where a single message could elicit over 500 more steps on a hot day relative to a colder day where it might have no effect. Sit less messages, interestingly here, we see that on very hot or very cold days, they got their greatest effects. And quotes, same thing. The people had the biggest responses to quotes at the extreme temperatures. So here we see that the context that around the person, at least outside, is making a difference in how large their response is to these messages or how large the response is expected to be. Another factor that we've built into the model more recently is time of day. So we allow the estimates of message effects to vary by time of day. And you can see along the x-axis from 8 a.m. to 8 p.m., the expected effect sizes. And early on, the quotes were the messages that were moving this person. But after about 4 p.m., the sit less messages became a little more potent. Now, there's a caveat here that we have less data at the end of the day. It's a shorter horizon. So these estimates aren't as precise then. But understanding the time of day, the day of week, the weather conditions outside, person's recent behavior, and their historical responses to treatment can allow us to make better estimates of how they would respond to different messages at a given moment in time. And we compared what would happen if we just took everybody's data and mashed it together and generated the estimates. Well, we can do that. We can come up with estimates of weekend and weekday behavior. And although the font's a little small in these figures, you'll notice that the thing that jumps out to me anyways is that the magnitude of the responses is much more attenuated. You're only getting 50, 70 step increases at best when you use a generic model that combines everybody's data together. And this comes out a little more clearly in this table, where you see the 3 rows here are the different message libraries that we're sending messages from. The first column is the average of the estimated person-specific effect. This is the max effect, the steady state, from the move more message, the sit less message, or the quote on weekdays, and then on weekends. And in the generic model, you see where all the data gets mashed together and we just simulate the response. We get very similar estimates. But the story isn't in the means with these data. The story is in the range of possibilities. And you can see that move more messages on weekdays could have a pretty substantial positive effect on behavior. One person had a 239-step increase from move more messages. Another person would have a 263-step decrease if you sent a move more message on weekdays. And you see for all 3 message libraries, there is substantial variability. So picking the right message for the person at a given moment in time could be a game changer in terms of increasing the size of effects that we see from this intervention. So we looked at what would happen if we actually picked the most potent message for every person in our study. And on average, on weekends, you'd see about 300 step more in terms of an effect. Now, that's on top of the base effect of messaging, a 300 step per message benefit in favor of activity, just by knowing which message to send at each moment in time. On weekdays, the effects are a little more modest. 160 steps makes sense if you think about people being constrained in terms of what's possible because of other obligations like work. But if you think about sending 2, 3, 4 messages a day, we're talking about pretty substantial impacts. And that really comes clear when you go back to that study I mentioned earlier with the average effect on physical activity being around 1,300 steps in adults. If you take 4 messages that you can add a 300 step per message benefit to, you're almost doubling the intervention effect. And I would argue it's likely even more because the participants we study, we screen them very rigorously, self-reports and a 1-week accelerometer wear period to make sure that they are extremely low active to begin with. We're looking for the couchiest of couch potatoes in our studies. And what that means is not only do they have low step counts, but they have low variability in their step counts. So the effect sizes that were used in this review by Wright et al., they assumed from population level data, a step count standard deviation of 1,250 steps. And I can tell you that is much more than we see in our population where the average step count is around 3,500 steps. So we can have a much larger effect. So we've developed this precision intervention pipeline based on this idea that we want to know a person's goal, we want to know the context they're in, and we want to figure out what the right message is to send. So we specify a daily step goal for the person. We gather contextual data about their recent behavior, whether it's a weekend, weekday, the time of day, the temperature outside, whether it's raining. We feed that into a controller, which takes the coefficients from the system identification process and solves an optimization problem effectively to determine, do I send a message or not? We give the system a budget of, say, 4 messages a day and say, spend them wisely. And in an optimization framework, if you're not going to get a benefit from sending a message, you don't send it. So you might not even spend all 4 messages in your day's budget. But it tries to wait for the right moments to make sure it's going to get a bang for that buck. And at times it sends that micro intervention, a text message, and we capture the behavioral response on the wearable device and feed that back in as contextual data for the next decision 15 minutes later about how much a person might benefit from another message at that point in time. Now, this was a fine approach, but the problem or the challenge we have is that every experience we have in this world changes us. Who we are is an outgrowth of who we were. And those experiences are shaping our development and the systems regulating our behavior. So we're aging, we're changing. From school days or work days to weekends, we're changing our behavior. From summer to winter, we change our behavioral patterns and habits a little bit. As our health changes, whether we're injured, ill, or dealing with chronic disease, our behaviors change. Life events, I mean, unfortunately, these typically reduce physical activity, but the birth of a child, getting married, relocating, starting a new job, all of those pretty consistently reduce physical activity levels. Retirement's a little more ambivalent in terms of the findings. The pandemic, we were doing our first big study and COVID-19 broke out and kind of threw everything against the wall. We had to pause. We had some people who were in the middle of the trial and we were able to keep intervening because it was a digital intervention. So we had some data from before the pandemic was declared, and then the stay-at-home orders came in, and we kept getting data. What we found was that when we split the data up, that the way they regulated their behavior changed. So this is one person just picked to illustrate the point, but system dynamics changed for this person so that on weekends before the pandemic declaration, the sit less messages were the ones that got them moving. And they'd get about, looks like 140, 150 steps more from a sit less message. And it took about 3 hours for that effect to fully exhaust itself. After the pandemic, when they had the stay-at-home orders and they couldn't go to work anymore, they were in their neighborhood. Now the sit less messages weren't the magic trick for them. Now it was the move more messages, and you could get over 200 more steps by just prompting this person to move more throughout the day. So we need to go back to this intervention pipeline we developed, and we need to add the capacity to learn about how the context around the person's changing and how the person's changing in response to that context. So we've built in a second layer of adaptation where we take these behavioral responses and the messaging histories and re-estimate or re-identify the system periodically. We do it once a month and use that to update the controller. So we have a doubly adaptive intervention now. We adapt at the moment-to-moment level to decide on which message to send, but then on a slightly slower time scale, we're adapting the model that informs the decisions we make about those moment-to-moment interventions. One thing that was interesting, these are some newer data. These are 4 cases picked to make a point. We had people on the left side of the screen. These 2 people got 3 messages a day. They're randomly assigned to a group that got only 3 a day. On the right side, they were randomly assigned to get 6 messages a day. And the 3 colors are the 3 message libraries. And you can see as the study goes on from day 0 to day 180, the proportion of messages from each library starts to shift as the system's exploring a little bit what works for this person. And if it finds something that's working, it leans in. And we do have a bit of an exploration function in the decision so we don't get trapped in a model. But the system is learning the person. And whereas it had been sending for this person in the top right, or top left, excuse me, a lot of the red messages, I forget which library it was, let's say it's sit less, all of a sudden it learned about 2 months in, no, the sit less messages aren't doing what I initially thought they were, or the person's in different contexts. I'm going to change. And now it's giving fewer and fewer sit less and much more of the blue or the orange messages. The person on the right side of the screen, top right, they're an interesting case because they had a budget of 6 messages a day that they could receive. And the system realized that sending 6 messages a day was not going to help this person. So it didn't even discharge its full budget to help the person. So this is really interesting, having the system finding the right amount of intervention for people. Now, in the Roybal Center that we're starting, the focus of our work is not on behavior change during an intervention period. That's work that we've done already and is underway with other support. What we're really interested in getting into is what happens when you stop messaging people? What happens once the party's over and a person's not getting the support of an intervention anymore? How much do they return back to the prior level of their behavior? So how much is the post-intervention decay in their behavior? And what's left in terms of post-intervention residual gains? And this is where we've been thinking a lot about, this experimental medicine or science of behavior change approach, where our intervention is engaging a set of mechanisms, activating goals for activity that are leading to behavior change. But we need to also be making sure that the intervention approach of precision messaging is engaging some of the targets that are going to support adherence to behavior change once we stop sending the messages. Effectively, we're trying to help people rewire themselves by leaning into the patterns that the model discovers in their behavior, to help them form habits, to help them change their identity, to see themselves as a more active person. And we believe that by modifying those mechanisms, we're going to support post-intervention residual gains in step counts. So basically, we'll get people to stick with the behavior change instead of reverting back to pre-intervention levels. And one of the other tools we're using in this process, we're in the early stages of it, but it's generative AI. And we're trying to create a transparent and controllable prompt structure that allows us to engage very specific mechanisms of behavior change. So in this case, creating prompts that will activate urges to be active, activate goals to be active, and over the long haul, create more of an identity for physical activity in the people that we're working with and help them develop habits. So we're currently working to optimize the prompt structure so that we can activate those psychological targets of behavior change. The other thing we're doing is, as a part of the center, is working with Marty Slowinski and his team around mobile monitoring of cognitive change. This is John Haken in particular is on the team working on this with us. They've developed, with NIA support, fantastic app for ambulatory assessments of cognitive function. So we're hoping to be able to capture real-world cognition, just like we're capturing real-world context-sensitive behavior change, and not so much see that we're able to change cognitive performance, but hopefully we can improve the consistency of cognitive performance. And as other work progresses in identifying the features of cognition in midlife that predict risk for later life Alzheimer's disease and dementias, we can start to understand exactly which features of our interventions, which types of physical activity behavior change are going to be most effective in reducing risk. And the big barrier to that definitive trial validating physical activity is that we can't get people to stick to the behavior change. So our hope is that by having a more focused approach, targeting those mechanisms of adherence, the habits, identities, and so on, we're going to be able to support that. And our trick for doing that, or our strategy, I should say, is to use person-specific modeling and to be informed about the context the person is acting in. So I invite you all to stay in touch. This is a statue on the campus here, the Cube. There's one in Manhattan as well. We've created our own little cube as we try to work on the puzzle of Alzheimer's disease and solve the problem of getting people to stick to physical activity over the long haul, starting in midlife, so that they can have reduced risk later in life. And I want to thank you all for listening to me. I hope I've left enough time for us to have some great discussion now.
Perfect, David. That was excellent. Real tour de force, and thank you for setting the table for us to ask you lots of questions. I have a dozen myself already, and there's a few in the chat. So I'm going to take the liberty of asking one or two, and to get us going, and then we'll invite others to ask questions. There's a few in the chat as well, which as we go, I'll sort of pepper them through. So the first is a bit of a cynical question, and it is, and I asked this to, I'm an accidental behavioral scientist, and I asked this of somebody who comes from an applied field, but is perhaps less of an accidental behavioral scientist than I am. And so you showed a very nice sort of model where there's a message, and then there's this box of a mechanism of some sort, and then there's physical activity. And there's really two parts to my question. And so the first is, do we care what's in the box? And what I mean by that is we can hypothesize how these things work, but ultimately, as an empiricist, that I care about whether they do work or they don't. And the mechanism itself, or what's in that box, is somewhat irrelevant. So that's the first half of the question. I'll ask the second half of this question, and then have you react to both of them. Which is, I'm going to now sort of talk out of the other side of my mouth and say, well, there may be things that we learn from what's inside that box, which tell us something that is fundamental about human behavior, or which may then speak to habit formation or any of a variety of other things. And so I was wondering if you could react to that, just the framing paradigm, before we get deeper into the approach and the technology.
Yeah, it's a fantastic question, and one that I've actually had a kind of a reorientation around myself in recent years. At the moment-to-moment level, we're not going to be able to capture the fast timescale changes in any psychological processes that are underlying behavior change. So at that level, no, I don't care what's happening within the person, as long as I predictably know that this stimulus, this message for this person predictably leads to this amount of behavior change. That's enough for me at the momentary level. Now, zooming out at a slower time scale, do I want to know about the mechanisms? Absolutely, because that's going to inform how I develop messages and the content that I put into the messages. It's going to inform decisions about how long the intervention might need to last to help people form habits. But I started my career and I would have said, no, I absolutely need to know what's in that box. And now I'd say very much it depends. And I see Constantino's on the call. Maybe he wants to add a little bit, because he's the one who introduced me to this idea of not needing to know what's inside the box.
I mean, I don't know how much I can add to this right now, but from my own point of view, there isn't enough we can measure to actually try to do this fast. Let's put it another way. To design an intervention that uses a model that is more detailed in terms of what's happening inside the person's brain as this is going, would require estimation of variables for which we cannot do it in real time. And so in that case, the best thing we can do, or at least the best thing I think we can do, is try to get models that approximate the behavior and that essentially work like a black box, where you put the stimulus and you see what is the resulting response. But there is not enough information to start trying to go and really identify the details inside that response. Because, I mean, even if you could do that for a person, to design an intervention, you cannot measure the variables needed in real time.
Great. All right, second question for me, and again, I'm going to encourage other people to raise their hands as we go, just so we can keep things moving. Otherwise, I'm going to keep on asking. So the second question, again, before we get to sort of technology, is really about how behaviors are related. And so, David, your work with Constantino in this case is focused on physical activity. I know you do other work focused on drinking behavior, I'm a general internist. I care about those behaviors. Our center focuses on medication use, so medication adherence. I care about healthy eating. I care about good sleep. I care about, any variety of other things, which I think we can all agree as evidence-based for healthy aging. And so there's sort of two halves to this question too, which is how do you think about the person-specific responses to different behaviors? And of course, we can anecdotally all describe individuals who will adhere to one but not other ones of these behaviors for any variety of context or person-specific reasons. But is there a unifying way that we can think about this? Because the worst thing in the world we could imagine is texting people every 5 minutes for each one of their specific behaviors. And of course, a model could optimize that itself. But that as a general matter, if we had a representation of a behavioral phenotype that colored response to multiple health behaviors, there may be efficiencies and sort of off-target effects, which could be pretty powerful. And so I'm wondering if you could react to that as a general construct.
Yeah, I mean, there's a whole area of work on multiple behavior change, and there's a pretty consistent finding that health behaviors tend to cluster together. Very often, if you're exercising, you're eating well, and so on. The one exception might be alcohol use, where alcohol use tends to hang with being physically active, and there's very little evidence that alcohol use is health enhancing. But I think that where that literature maybe has its bounds is that it's largely based on static snapshots of behavior over time and not the dynamics of behavior change. So it's multiple behavior clustering, but not actually simultaneous multiple behavior change. That possibility of spillover from one behavior to another is an intriguing one. And we could start to see that there's people who you get to be more active, they're sleeping better that night as a consequence. We haven't gone that step in our work. There is some work in that space, but not doing the really fast time scale intervention, the just-in-time based approaches. So I think that's the distinction I would make, is about the multiple behavior clusters and the clustering of change processes. And that's an exciting area to do work in, I think.
Yeah, great. Awesome. All right. I'm Deepak. Just before I turn to you, I'm going to ask a couple questions from the chat. One from a colleague at Johns Hopkins, who's a member of the Stakeholder Engagement Core, and asking, I think, probably a level-setting question, I presume, about the social ecological model as it's generally constructed. But David, could you comment a little bit about research or frameworks that help us think about how community adds to either context or individual behavior?
Yeah, I mean, I think that fits into that, social factors and the social context, and understanding, one way you might build that into a model like we've used in our approach is thinking about proximity to keep people who are, are going to support your activity or maybe who'll detract from it, and understanding that their presence or absence as contributing to vulnerability or opportunity for you. I'm trying to think where else people might have brought some more into. I mean, I think the overarching framework of a lot of behavior change work now is the COM-B model. Susan Mickey's approach, saying, you have to think about behavior change coming from a person's capabilities, opportunities, and motivation. And I think that the interplay between opportunity and motivation is probably where that social space has its greatest influence. And unfortunately, at this point, we don't have a lot of work looking at interactions between those three factors: capabilities, opportunities, and motivation. A lot of times we take a little more siloed approach. So I don't know if that's helpful at all, but that's where I'd start thinking about it.
Yeah, maybe I would just add to that I would I think community is part of context, and a lot of traditional behavioral science models, even health belief model amongst others, or social ecological model, sort of recognize the multidimensional layer of how these things interact. And community itself may be a cue, it may be an enabler, it may be any variety of other things. And so I think maybe to answer Lily's question here, that I think what she's getting at is exceptionally important. We all acknowledge that community and context is really important, but I think community is just another word for context in some ways, and a lot of the traditional models kind of have acknowledged that. So one more question before I turn to Deepak, and thank you, Lily, for your question. So from Felipe, is there an asymptote to step response to messages that the Jedi cannot overcome? So eventually, does this class of intervention stop working? Great question.
This sounds like the idea about getting fatigued by the intervention. Talked about this a little. Constantino, do you want to tackle that one first? I mean, in terms of people habituating maybe and not having a response anymore?
I mean, this is something that we've discussed before, obviously, and that we might see. I see another thing that can happen, which is people not needing messages anymore so internalize the behavior and not needing messages anymore to do activity. And then you'll see that the model should eventually show that they are not responding to messages because they are doing exercise whenever they want, in not having to rely on the message to do it. But I don't know, you people in here are much more experienced than I am in human behavior. I'm a mathematician from the electrical engineering
Well,
side.
I think one of the topics we've talked about, though, is the optimal amount of data to have and when you can start forgetting a person's historical steps. Do we need 6 months of data? Do we need a year of data? At some point, maybe that old data doesn't need to be a part of the model as much anymore, and that might be informative. You might be actually holding back on predictions by using giving the past too much weight when you have more recent data available. So that idea of when to start forgetting has come up in some of our discussions.
I was interpreting this in a different way. Yes, I mean, I do believe that people response to messages is not time invariant. It changes with time, and eventually you should discard old data and use more recent data to inform your intervention algorithms. And this is something that I think it happens and that we definitely should take into account. Now, what is the forgetting factor for this behavior? For this thing happening? I don't know. I don't have any idea right now.
Yeah, I think that's an open question. It'll be a fun
It's
one.
an open question. So it's something that we are actually right now analyzing data, trying to see how the models change with time, in making sure and trying to see if there is a pattern that we can get out of that. But that's ongoing.
But in theory, the beauty of these models and others that are related to them is that they can continue to adapt over time to as soon as you look like you're falling off the wall. So it doesn't it may asymptote in terms of maximal effect, but that doesn't mean that they can't maintain behavior over longer periods of time.
That's true. That's true.
Yeah. And the objective, I mean, the ideal objective on an intervention like this is that whatever mechanism you have adapts as you go on, because your response to whatever stimuli you are using is going to change with time.
Yeah, exactly. Deepak, please.
Thank you, David. Great talk.
Thanks.
So as you were talking, one of the things I was wondering is how, if you have any thoughts or experience on how the total volume of interruptions or notifications in general impact the whole process. So, it's just not, I think there's always this question of interruptibility and how much is the total interruptibility that somebody can take before an additional interruption becomes too much. And among the many things, there's many things about behavior that's not measurable, but I wonder if one of the things one can actually measure is how often, in addition to your notifications, how often the individual is actually getting interrupted by a variety of other notifications on a phone, what have you. So, it's entirely possible that I'm just curious whether there's an overall impact of, that you can sort of think about your notifications and how other notifications or the volume of other notifications impacts the step response?
Yeah, I mean, I think point's really well taken because we're in an attention era right now, or an attention economy where so many groups are fighting for our attention through our devices. And personally, I hate notifications. So it's kind of ironic that I'm sending them out to people and spending so much money doing it each month. So we've talked to participants to get their input. We've tested, we tried 8 per day in one study. We compared 3 versus 6 in another. We were using 4 currently. In the comparison we did of 3 versus 6, this is work I need to go back to, so we might need to edit this recording afterwards, but I don't think there was a difference in terms of the efficacy. So I don't think it mattered for behavior change. So you could argue that the last, messages 4, 5, and 6 weren't really adding value. They might have been, had some incremental value at the momentary level, but the juice might not have been worth the squeeze in that case. When you think about the burden that people experience from the constant interruptions. I don't know. I think part of the idea is that we want to minimize the false or the inert messages that we send. So really trying to be selective, sending them in situations and at moments when people are, by virtue of their past history, likely to respond. In other work we've done with JEDIs, though, I've taken a different approach where instead of trying to push messages, we set a regular schedule and we cancel them when we notice people are doing the behavior already. So there we see it actually as a negative reinforcement model where we're withdrawing the unpleasant, aversive experience of being disrupted when you're doing just fine. And we've seen that not only supports behavior change, that's our fluid intake work, but also habit formation because people are getting a reward for doing the behavior that's desired. So I don't know what the optimal number of messages to send is. I suspect there's some noticeable individual differences. Some people might be much more tolerant than others, but I can't say that we haven't found a sweet spot where it's definitely too many or where there's a dip in efficacy because it's too much. At least with these kinds of text messages. We published a study a couple of years ago, Constantino and I, with some students showing that with watch-based prompting, there was such a thing as too many prompts on the wrist. 2 to 3, or I'm sorry, about 3 prompts a day was the max there. And if you got up to 4, 5, 6, you started to see diminishing returns. Actually, see suboptimal effects. It was kind of an inverted U. But that was with a very specific watch-based prompt to self-monitor their behavior, which is a little different than just these attention grabs that we do where it's just a one-way communication.
Great. All right, I'm going to take the liberty of asking the last question, and it's one, David, that I began to ask you in another forum, and maybe Constantino is the right person to answer this with you.
Yes.
And thank you, Constantino, for being a guest speaker with us today. So my question is really a technical one about the difference between the controller system approach that you use and other similar approaches, which have a very similar intent, namely a model that we use, which is reinforcement learning. And in fact, David, just a minute ago, you used the word reinforce. Even the intent of these models is exactly the same. They have person-specific terms in them. They may have fixed effects for characteristics of individuals. So the model learns and adapts over time, both at the individual level, but also at the group level. And so the explainability of the model, then, if you look at the R-square of a model in terms of predicting behavior, even in the aggregate, leave aside the individual, that improves over time. And I'm just wondering if you could help orient us to this approach, and is it similar to or different, and or whether or not you're aware of others? Are there other sisters to these approaches that are really trying to achieve the same thing?
I'll defer to Constantino on this one.
So one of the main things that makes me pause when using reinforcement learning in such a setup, to me, is the lack of enough individual data to train an individual model for a person. So let me put this in context and or be a little bit more careful. So as we were discussing, we are seeing these behaviors that are very, very different. I mean, extremely different in some ways, having completely different responses to different type of messages. And if we are using a reinforcement learning model where we need to have a lot of data to learn the model, and we do need a lot of data to do reinforcement learning, or at least the algorithms I know about it, I think this individual part of the model gets a little bit, not totally obviously, we are using tailoring variables in there and personal variables, but gets a little bit washed. In our case, we are identifying models that are specific for each individual. So by doing that, we can get obviously interventions very targeted to the individual, but at the same require much less data to come up with an approximate model.
Great.
So that is the advantage that I see from our side. It's the data. We use simpler models, but much more targeted to each specific individual.
Perfect. Well, that's an excellent end. So David, thank you so much. Constantino, thank you also for being here, for sharing your joint work and those of your colleagues. I think this was an excellent way to bring together so many things that we do in our collective research worlds. And thank you for being with us today. I hope everyone else has a great rest of the evening, and we'll see you all soon.